Claude Code writes your code. ChatGPT browses the web. Devin deploys entire apps. They look completely different. But under the hood, they all use the same 4 design patterns. Tool use, RAG, planning, multi-agent. That's it. 4 patterns. And by the end of this video, you'll see exactly how each one works. You'll have real code for all 4, and you'll get a cheat sheet that maps which pattern to use for any project you're building. 2 years ago, AI agents were a research paper. Today, 40% of enterprise apps will have AI agents by the end of this year. 62% of companies are already experimenting, and every single framework, LangGraph, CrewAI, Claude Agent SDK, OpenAI Agents SDK, they're all just different implementations of these same 4 patterns. Andrew Ng called them out first. He said these 4 patterns would drive the next wave of AI progress. He was right. But here's the thing most people miss. You don't need a framework to use them. You just need to understand the patterns. Because once you see them, you can build agents in raw Python. No dependencies, no lock-in, just the patterns. Let's start with the most fundamental one. Pattern 1, tool use. This is the pattern that turned chatbots into agents. Without tool use, an LLM is just a brain in a jar. It can think, but it can't do anything. Tool use gives it hands. Here's how it works. You define a set of tools, functions the LLM can call, search the web, read a file, query a database, send an email. The LLM looks at your request, decides which tool it needs, generates the arguments, and the system executes it. The key insight? The LLM doesn't run the tool itself. It generates a structured request, usually JSON, and your code handles the execution. That's the safety boundary. Let me show you. Here's a tool use agent in 30 lines of Python. You define your tools as functions. You describe them to the model. The model calls them. You execute. Return the result. Loop. That's the entire pattern. Every time Claude Code edits a file, that's tool use. Every time ChatGPT searches the web, tool use. Every time Copilot runs your tests, tool use. And here's why this pattern matters so much. 87% of IT leaders say tool interoperability is crucial for AI agent adoption, because an agent that can't connect to your systems is just an expensive autocomplete. Tool use is pattern 1 because nothing else works without it. Pattern 2, RAG, Retrieval Augmented Generation. If tool use gives the agent hands, RAG gives it memory. Here's the problem RAG solves. Ask any LLM about your company docs, your codebase, your data, and it'll confidently make things up. It hallucinates, because it only knows what it was trained on. RAG fixes this with an elegant trick. Instead of retraining the model, you just hand it the right documents before it answers. 3 steps. Step 1, retrieve. Your documents get chopped into chunks and stored as vectors, numerical representations of meaning. When a question comes in, you find the most relevant chunks using similarity search. Step 2, augment. Those retrieved chunks get injected directly into the prompt. Now the LLM has evidence, not just vibes. Step 3, generate. The LLM reads the context and produces an answer grounded in your actual data. No hallucination. Here's the code. An embedding function turns text into vectors. A retrieval function finds the closest matches, and the generation step combines them into a grounded response. 20 lines. That's RAG. Claude Code uses RAG when it reads your Claude.md files and codebase. GitHub Copilot uses RAG when it indexes your repository. Every enterprise chatbot that answers questions about internal docs, RAG. 80% of enterprise AI apps already use this pattern. It's not a trend. It's a requirement. But here's what's interesting. Tool use and RAG are both reactive patterns. The agent responds to what you ask. What if the agent could think before it acts? Tool use and RAG are powerful, but they're both reactive. The agent waits for you to ask, then it responds. The next 2 patterns flip that. They let agents think for themselves. And that's where things get really interesting. Pattern 3. Planning. This is the pattern that separates a tool from a teammate. With tool use, you tell the agent what to do. With planning, you tell it what you want, and it figures out the steps. Here's the core idea. The agent receives a complex goal. It breaks the goal into subtasks. It sequences them, and then it executes step by step, checking progress and replanning when things go wrong. Think about what happens when you tell Claude Code, add authentication to my app. You didn't say which files to edit. You didn't list the steps. Claude Code analyzes your codebase, identifies the auth patterns, creates a plan, maybe 10 steps, and executes each one, adjusting if a test fails along the way. That's planning. Let me show you the code. A planning agent has 3 phases: decompose, break the goal into steps; execute, run each step using tools; reflect, check the result, and replan if needed. This loop is the heart of every serious AI agent. GPS navigation? Planning. Devin writing a full feature? Planning. Claude Code's plan mode? Planning. And here's the thing that makes planning so powerful. It composes with the other patterns. A planning agent can use tool use to execute its steps. It can use RAG to gather context before planning. The patterns stack. Which brings us to the final pattern, and the most powerful one. Pattern 4. Multi-agent. This is where it all comes together. Instead of one agent doing everything, you build a team of specialized agents, each with their own tools, their own knowledge, and their own role. Think of it like a software team. You've got a researcher who searches and gathers information, an analyst who processes data, a writer who produces the final output, and a manager who coordinates them all. Each agent is an expert at one thing. The manager delegates, collects results, and makes decisions. Here's why this works. A single agent trying to do everything hits the context window ceiling. Its instructions get bloated, its tools conflict, it loses focus. Multi-agent solves this the same way microservices solved monoliths, by splitting responsibilities. Let me show you the code. Each agent is its own instance with its own tools and system prompt. The manager orchestrates the workflow, routing tasks to the right specialist. In the real world, Devin uses multi-agent internally, separate agents for coding, testing, and deployment. CrewAI's entire framework is built around this pattern, and Google just published 8 multi-agent design patterns as their official architecture guide. Here's the most important thing about Pattern 4. A multi-agent system is patterns 1 through 3 combined. Each agent uses tool use. Some agents use RAG. The manager uses planning to coordinate. Multi-agent isn't a separate pattern. It's the composition of all the others. So which pattern should you use? Here's the cheat sheet. If your LLM needs to interact with external systems, APIs, databases, files, that's tool use. Start here. Every agent needs this. If your LLM needs knowledge it wasn't trained on, your docs, your code, your data, add RAG. If your task has multiple steps and the LLM needs to figure out the sequence, add planning. And if the task is too complex for one agent, different skills, different contexts, different tools, go multi-agent. But here's the real insight. You almost never use just one. Claude Code, tool use plus RAG plus planning. That's 3 patterns in one product. ChatGPT with plugins, tool use plus RAG. Devin, all 4. The power isn't in any single pattern. The power is in how you combine them. Let me show you what a real agent architecture looks like when you combine all 4. This is the pattern behind most production AI agents in 2026. At the base, you have your tools, APIs, databases, file systems. Above that, a RAG layer that gives every agent access to relevant knowledge. A planning layer that breaks complex goals into steps. And at the top, a multi-agent orchestrator that routes work to specialized agents. Each agent has access to the tool layer and the RAG layer. The planner coordinates them. The orchestrator manages the whole system. This is the architecture behind Devin, behind enterprise AI platforms, behind the agents that are actually shipping in production right now. And you can build it yourself, starting with just pattern 1, tool use, and adding layers as you need them. 4 patterns. That's all it takes. Tool use gives your agent hands, RAG gives it memory, planning gives it a brain, and multi-agent gives it a team. Every AI agent you'll ever build or use is some combination of these 4. If you want to go deeper, I've covered AI agent frameworks, RAG pipelines, and agentic architectures in detail. Links are in the description. And if you want to see me build a production agent using all 4 patterns from scratch, subscribe. That video is coming next. I'm Tech Whistle. Go build something.